Hi guys, my name is Terry. In this video, I'm going to go through the SPM trial paper, year 2024 for Pinang paper 1. So let us begin with the first question. This is from Form 4, Chapter 6, Linear Law. So we are given a straight line that is obtained when this equation, or should I say this curve, is converted to linear form. So we're supposed to find the x over y intercept, that is the y-intercept here. We call this the big Y. We call this the big X in terms of h. So we can start off by rewriting this. You notice that your big Y is x over y, meaning I need to bring this y down and bring the rest of this up. So I know it's a bit hard to see. Maybe I rewrite here for you. Y equals 2x over 3x squared plus h. I'm going to copy the whole 3x squared plus h. I'm going to bring it up. I'm going to bring my y down. At the same time, I'm going to bring the x over. The 2 over x we're going to maintain that because we need y over x over y. So bring the 2 down. So it's going to look like this. You have 3x squared over h divided by 2 equals to x over y, because we need to make x over y as a subject. Now, notice to convert to linear form, we could write in the form of y equals mx plus c. So that's where we have to split this. Yeah, we're going to split this. So I'm going to rewrite x over y on the left, split this into 3 over 2x squared plus h over 2. So this is your big Y. This will be your gradient. This will be your big X. And this will be your C. So when you convert to linear form, you can see C represent your y-intercept, which is what we're finding out. We're finding the x over y-intercept, which means the y-intercept here in terms of h. So therefore, you can say that your C or your x over y-intercept is just h over 2. Yep, I've got my part A done. Okay, part B is supposed to express your h in terms of P and Q. Notice P and Q, they are the x and y coordinate of the straight line that you've got. So we need to substitute inside your equation of straight line. But again, it's a bit hard to see from here because this is x over y. A lot of people tend to get confused, right? They tend to sub in, for example, x with p, y with q plus 1, which is actually wrong. Huh? We can't do that. Why? Because your x over y is your big Y now, the variable in your y-axis. The x over y is this. This is your q plus 1. The entire x over y is now q plus 1. The x squared is your p. So to avoid that problem, right, or substituting the wrong variable inside, it's better for us to rewrite x over y as big Y, and then your x squared as big X plus h over 2. And from here, I'm going to sub in the coordinate. Your coordinate is p and q plus 1. That means your big Y is q plus 1. Your big X is p. Then you plus with h over 2. We can then multiply everybody by 2. So 2q plus 2 equals 3p plus h. Make h as a subject. H is 2q minus 3p plus 2. Okay, there you go. You got your h in terms of P and Q. Okay, moving on to question number 2. This is from the chapter Coordinate Geometry, Form 4, Chapter 7. Okay, you are given that 3 points PQ are, it represent a right angle triangle on the Cartesian plane. So we are also given equation of QR is y equals 3x minus 8. You're supposed to find coordinate point R. Okay, so notice when you see a 90-degree here, meaning we need to use m1 dot m2 equals to -1. They're perpendicular to each other. But we need to first identify the gradient of line QR. Your equation of QR is given. Okay, let me write here. Equation of line QR is y equals to 3x minus 8. we need to find the gradient of this line. Very simple. This is already in the form of y equals mx plus c. So your gradient of QR is 3. All right. Your perpendicular line is PR. We take QR, we multiply with PR. The result is -1. The gradient of PR is therefore -1/3. Okay, so we know the gradient of this line. But to find the coordinate, right, we need to find out the equation of straight line PR first. And then we solve simultaneously with equation of QR. Now, your PR, right, we know the gradient. We know point P, we know 1 point. So we can use y minus y1. Your y1 is 4. Your gradient is -1/3. X minus x1. Your x1 is -1. So for me, I'll multiply the 3 over. I rewrite 3y minus 12 equals minus x minus 1. Your 3y is minus x plus 11. And I'm going to call this equation number 1, call this equation number 2. Because we need to now solve them simultaneously to find the coordinate of point R. So let us sub equation 1 inside equation 2. Your y is 3x minus 8 equals to -x plus 11. 9x minus 24 equals minus x plus 11. Bring the -x to the left-hand side. 9 plus 1 is 10. 24 negative, you bring to the right. 24 plus 11, that is 35. X is 35 divided by 10, that is 7/2. Okay, so once you got your x value, we need to find our y value. Let us sub inside equation number 1. Your y is therefore 3 times 7/2 minus 8. This is 21 minus 16. 21 minus 16 is 5. 5/2. So therefore, coordinate point R is 7/2, 5/2. Yeah, it's in the form of fraction. All right. Next, we're finding area of triangle. Now that you know all 3 points, so to find area triangle is relatively easy. Just use the formula. Area is half. Pick 3 points, any 3, but any sequence. But for me, I would choose anti-clockwise because anti-clockwise is going to be positive. If you choose clockwise, it's going to be negative. But even though you get negative, you can just treat it as modulus because it's a determinant. Basically, it's a determinant of a matrix. So we just treat as positive because area can't be negative. So here I start with point B, -1, 4. I continue with point R, 7/2, 5/2. I repeat with point Q, 5, 7, repeat with the first pointer, -1, 4. Okay, so let's multiply downwards, right? This will be, now remember we multiply this way down first, then you minus multiply this way up. And please show your working. In SPM, you need to show the multiplication. Nowadays, -1 times with 5/2, 7/2, you times with 7, 5, you times with 4, minus the other way up, 4 times 7/2, 5/2 times with 5. Okay, let me move this over a bit. Followed by 7 multiply with -1. So that we can count using our calculator. Let me show you here. Let us use -1 times 5/2, -5/2. Then you add 7 times 7, 49/2, followed by 5 times 4, which is 20. Then you minus 7. 4 times 7 is 28. 28 divided by 2, I think I'll just write 14 here, 14. And then 5 times 5, 25/2, followed by -7. Okay, so with that, I got 45/2. But remember, there's a half outside. So half times 45/2, this is 45/4, or you can write as 11 1/4 square unit. Okay, this is question number 3 from Form 4, Chapter 2, Quadratic Function. Diagram shows a quadratic function, fx equals x minus 3 squared plus m, where m is a constant. So find the equation of x is symmetric. So this is quite easy. You can see from the function here, your fx is written in vertex form. Your a coefficient of x squared a is more than 0. So therefore, your fx has a minimum value. And that minimum value is m. And this occur when the one inside the bracket, x minus 3 is 0, x equals to 3. So that x equals to 3 is the equation of axis of symmetry. Yeah, only 1 mark. Now, next, find the value of k. Hey, notice that is a root of your function, right? Is the x-intercept. So we can use the equation of axis of symmetry here, or we can find equations axis of symmetry here from the graph in terms of k. Yeah, we can do that by taking the midpoint of your roots, k plus 8 divided by 2. And this value here must equals to your axis of symmetry that you got from the equation, which is x equals to 3. So we're going to write k plus 8 over 2 equals to 3, multiply over, you get 6, 6 minus 8, you get negative 2. All right, still quite easier. Now, next, state the change in the value of k. If the value of m, there's a mistake in the paper here, is value of m, you can see the Bahasa version is m, decrease, justify your answer. So what will happen to k if you reduce your m? Now, m is actually your vertex, right? So when m reduces, what will happen is the graph will be shifted down, right? The graph is shifted downwards, correct? So when you shift the graph downwards, let me draw another one like this. So what happened is that the shape of the graph actually doesn't change. Yeah. So maybe I write here, since the shape of the graph remains unchanged, So what actually happened here? Now you notice the roots, right? The graph is moving away from the axis of symmetry. Yeah. So we can say the roots are further away, right? Further away from the axis of symmetry. Okay, so you notice your k value will be, or your roots is now k value. Right? Your k value is not the same as from part A because your m has now changed. So it will now be further away, yeah, from the axis symmetry is more towards the left. Then we can say, therefore, the k value decreases. Yeah, k value, or the value of k, I would say the value of k decreases. Therefore, the value of k, sorry for the ugly handwriting, the value k reduces. Okay, so you didn't increase. I mean the shape remains unchanged, just shifting it down. So therefore, the roots are further away from axis symmetry, and your k will be now further, right? Or should I say reduces? Before this is -2, now could be -3, -4, and so on. Okay, question number 4. This is from Form 4, Chapter 1, Function. So you are given that fx equals to 3x. You're supposed to find f2x, f3x, f4x. So let's begin by finding f2x. Remember, this is called a iterative function or repeated function. So f2x simply means fx. You're putting fx inside fx. My fx is 3x. I put it inside 3x. Yeah, think bracket. F bracket is 3 bracket. If you put 3x here, you need to put 3x here. So that will give us 9x. Then let's continue with f3x. f3x, you can either put f2x or you can put f2 fx, up to you. So I'm going to write f2. I already know my f2. My f2 is 9x. And if you put 9x inside here, oops, if you put 9x inside a bracket, wait, you need to put 9x inside here. Okay, so let me just show you here. If this is 9x, this is 9x. So that will give us 3 times 9x, 27x. That is number 2. Let's do f4, number 3, f4. f4x means f3x. Since we already have f3x, which is 27x, we take 3 times 27x, that is 81x. Up to here, still okay, still quite easy. Now, next, by examining the pattern of f2, f3, f4, deduce fnx, where n is an integer. Okay, so we are looking at a pattern here. We know your f1, right? This is part B. Your f1x is 3x. So I want you to think of it as 3 power 1x. Your f2x is 9x. 9 is 3 power 2. Your f3x is 27x. 27 is 3 power 3. Your f4x is 81x. 81 is 3 power 4. So therefore, what is fnx? There's a pattern here, right? So f1 is 3 power 1, f2 is 3 power 2, f3 is 3 power 3, f4 is 3 power 4, fn is 3 power n, and your n is an integer. So 1, 2, 3, and so on. Yeah. Okay, simple. Okay, question number 5. This is from Form 5, Chapter 6. Yeah, Form 5, Chapter 6, Trigonometric function. So now let's begin. We are given y equals to 2 cos 3 over 2x, and your x value is between 0 to 2 pi. Let's sketch a graph, right? So before we draw the full version, I like to draw part by part to help you to understand how this graph works. Okay, so let's begin by drawing the basic y equals to cos x. We know cos graph, it starts from 1, it goes down to -1, passes through 0 here, and come back up. This is from 0 to 2 pi. Now, the moment you have a 2 in front, so what happened is that you stretch it up by 2, your amplitude is now 2. Yeah, amplitude is the maximum displacement from point O, from the 0, the line of equilibrium, if you like. So it's now stretched higher. Now, next, what is the effect of 3 over 2? Now, this 3 over 2 determines the number of complete cycle from 0 to 2 pi. So let me just sketch for you. So it looks like this. 3 over 2 pi. Let's do a small sketch first, then we draw a bigger version. So it's 1.5. Because 3 over 2 is 1.5. So this is 2 pi. Stop at 2 pi. Now, another way of thinking is you can think of it as period. Now, we know period is given by 2 pi divided by your b. Your b is 3 over 2. So when you divide by 3 and then you times 2, you get 4 over 3 pi, meaning you actually complete one cycle here at 4 over 3 pi. Now, one cycle for cos is 4 stroke, down, down, up, up. That's one cycle. So here we go to do 1.5 cycle. That's why we have to draw like 6 stroke. Okay, so this is a simple version, smaller version. Let's draw the bigger version over here. So please use a ruler, because when I draw a sketch like this, yeah, it may not be very May not be very nice, may not be very accurate because I'm using freehand, right? So, okay, horizontal. Okay, my line is not very straight. Okay, so make sure you divide into 6 equal parts. So something like this. Okay, 6 equal part. This is 2 pi. Maximum 2, minimum -2. Okay, maybe my 2 on top, I push it a bit further. Oh, or should I just put the 2 below nearer? It's a bit too far. Okay, I just put it here. Okay, now let us begin from here. For me, I will plot the point, yeah, to make sure that my graph is balanced, because some students, they draw the graph like this, you know, like, should I say, one side is longer, another side is shorter, yeah, not balanced. So you want to make sure that they're even, right? We plot the first point, second point, third, fourth, fifth, sixth, seventh. So you curve it like this to, okay, looks like this is a bit too long, so I need to stretch it a bit, make it a bit shorter. Up. Now this takes up some practice, yeah, to get a nice looking curve. Okay, may have to do it a few times. Another thing is, if you can use a thicker pencil, when you use a 2B pencil, thicker pencil, you just hide your the ugliness, right? So it will look a bit more smoother. Now, if this is 2 pi and you divide into 6 equal segments, 2 pi divided by 6 is 1 pi over 3. So you keep multiplying, you know, or adding pi over 3, pi over 3 plus pi over 3 to pi over 3. This is pi. This will be 4 pi over 3, which is equal to our period here. We've already calculated that. Then you plus another pi over 3, you get 5 pi over 3. So there you go. My graph is complete. So this is 2 cos 3 over 2x. Now, next what I need to do is I need to determine the number of solutions by first drawing a suitable equation straight line. Now, that equation of straight line can be found from here. Look at this equation. Remember, I need to rearrange the equation such that one side of the graph is equals to the original function here, 2 cos 3 of 2x, right? One side of the equation. Another side will be my straight line. So starting from this equation, yeah, that I have, I'm going to multiply everybody by 2. So when I times 2, I get 2 cos 3 over 2x. 1 over 2 times 2, I get 1. This is x over pi. So your suitable equation of straight line is 1 minus x over pi. Let us take a table of values, x and y. This is 0. We start with x equals 0. Then we follow by 2 pi. So when I put 0 inside, I'll get 1. If I put 2 pi, I'll get -1. So this is 1. This is -1. Now, let me use a blue color pen. This is 1. This is -1. All I need is a straight line. So I'm going to use a straight line from here. It's look like this. Okay, maybe can be better. A bit lower. Because my one doesn't look very good. Yeah. Okay, I think it's okay lah. Yeah, not too bad. So your straight line, you notice it intersect the curve, the cos graph, right, at 3 separate points. Remember, the number of solution is the number of intersection. If they intersect 3 times, you have 3 solution. So with that, we say our number of solution is 3. Okay. Okay, question number 6. This is so from Form 5, Chapter 6, Trigonometry, and it's also related to the graph. Okay, so here we are given the graph of y equals p sine qx for x between 0 and 2 pi. You're supposed to find the value p and q, and then write the equation of the trigonometric graph. Okay, now you can see p is your vertical stretch. And another thing is that your graph here doesn't start, a normal sine graph, right? You go all the way up from 0 down. So this is a positive 1 sine x. But the moment you have a negative, right? So the graph will go upside down. Instead of going in the positive direction, it goes downwards in the negative direction. So we know for sure your p will be negative. Yeah. Another thing is that your amplitude, when you stretch it, you can see you stretch it. Initially, it is -1 and 1. Now you stretch it to -3 and 3. So based on this, we know that your p value is -3. Yeah. So yeah, I know why. I don't know why they give 3 marks. This is supposed to be only 1 mark for each. 1 mark for p, 1 mark for q. Supposed to be 2 marks, but they give 3 marks. Okay, perhaps maybe they, if you miss out negative, negative, you get 1 mark. 3, you get 1 mark. Right? Perhaps that's the case. Now, how do you write? Oh, okay, sorry. There is another one. Sorry. You have to write equation trigo. Yes, so this is 1 mark, 1 mark, and equation of trigo is 1 mark. Sorry. So how about your q? Q represent the number of complete cycle from 0 to pi. Now you can see one cycle for sine is 4 stroke. Yeah, this is 4 stroke. You can see from here, 1, 2. But this is 1.5. So we can actually straight away say your Q is 3/2. Another way of thinking is to use period, right? But period here also not that straightforward because you cannot find directly from the graph. You need to calculate or estimate. You see, this is actually 1.5. So 1.5, should I say down, up, up, down? You can see this is pi. This pi going to divide by 3. This is 2 pi over 3. Therefore, this is 4 pi over 3. So you're going to work it out first. Then you say your period is 2 pi divided by q, and that is equal to 4 pi over 3. Cancel them. Yeah, I cancel 2 pi and 4 pi. I got 2, right? So 1 over q is 2 over 3. Q is 3/2. Okay, another way of doing, but I think this is a lot slower. Now, next, find the equation of your trigo graph. We already know your p, we know your q, just sub inside. Your p is -3, your q is 3/2. There you go, your y is -3 sine 3/2x. Moving on to question number 7, this is from 4 chapter 8 vectors. Your given vector u and w, where m is a constant, you're supposed to express u plus w in terms of m, right? Excuse me. Now, let's begin by finding what is u plus w. Your u is m plus 1 -9. Your w is m1. So let's add them up. Very simple. M plus 1 plus m, that'll be 2m plus 1, minus 9 plus 1, that will be -8. Okay, so that is your u plus w. Now, then you're given that magnitude u plus w is now 10. So you're supposed to find the values of m. Okay, so remember, if vector r is xi plus yj, the magnitude of r is x squared plus y squared square root. So you should take your 2m plus 1, you square it, take -8, you square it, take the square root, the result equals to 10. Now I'm going to square both sides. Your 2m plus 1 square, 8 square is 64, 10 square is 100. Let us take 100 minus 64, you get 36. Square root of 36. Remember, whenever you square root, there are 2 possible answers. The value here can be -6. It can be +6, because -6 squared is 36. positive 6 squared is also 36. Yeah. So bring the bring the 1 to the right, you get -7. Your m is -7/2. That's the first answer. Second answer, bring the 1 to the right. 6 minus 1 is 5. 5 divided by 2. Okay, there you go. Two answers for m. Okay, let's move on to question number 8. So here diagram shows the area for throwing javelin in the school sports tournament. So distance throw is measured from point O. So the area, the shaded area is the area where the grass needs to be replanted. Calculate the cost needed to replant the grass. If the cost is 1 square meter, for cost for 1 square meter is 12.50 cents. So basically you're finding area of bounded by two concentric sector. You can see these two sector, they share the same angle, which is 30 degree. The first one has a larger or longer radius. You minus second one is smaller. The radius is 15. The angle remains the same at 30. Okay, so it doesn't look 30, it looks a lot bigger than 30. But anyway, we're going to start off by finding the angle theta, right? So for me, I'd rather convert this theta to radian straight away. 30 is in degree. When you convert to radian, you multiply pi over 180. Now, normally in SPM, you're supposed to use pi as 3.142, but in this case, they didn't mention. And if they don't mention, we can just leave it in terms of pi. We can just type it in your calculator. So your area, first, let's calculate the area, is half R1 square. Your R1 is 30 square theta. Theta is pi over 6. Minus half R2 square. Your radius is 15. You square it. Theta is pi over 6. But when you type this in your calculator, you can just use half pi over 6. I would just factorize my pi over 6, right? Type in pi over 6. Then I multiply with 30 square minus 15 square. So with that, I got 225 over 4 pi. 225 over 4 pi. Just leave it in terms of pi first, because we need to now multiply with the cost per square meter. So this is the cost, this is the area, right? If you change the decimal, it's about 176 meter, 0.7 meter, right? Your cost in RM will be 225 over 4 pi multiplied by 12 ringgit and 50 cent. So multiply by 1250, I will get 2,208.93. 2,208.93. Yeah, that is the cost involved. Now, next in the event, Shafiq made a new record with a throw of 44 meter. So the school management will build an arc to mark the distance that has been achieved by Shafiq. So find the length of arc. Okay, so he managed to throw 44 meter. This 44 meter is thrown from here, from point O. Maybe I just show you here. I don't know, maybe around here, 44 meter, right? So they're going to draw an arc and build arc here. So this is also 44 meter, right? So very simple formula for length of arc. The length of arc S equals to R theta. Your radius R is 44. Your theta is pi over 6. Just use your calculator. 44 times pi over 6. Yeah, my answer is 23.04. Yeah, 23.04 meter. That's the length of arc that is built. Okay. Okay, this is question number 9 from 5, chapter 2, differentiation. You're given a curve y equals 2x plus b over x squared has gradient function of this, right? That means you know your dy dx, okay? B is a constant. In fact, you're given the y, you're given the dy dx value. You don't have to differentiate anything for now, right? You're supposed to find the value of b. Okay, but the thing is, yes, you have to differentiate your y and compare with your dy dx, right? So let's begin. Your y is 2x plus b over x squared. The moment you differentiate 2x dy dx, you get 2. Differentiate b over x squared, you get a negative. B times 2 is 2b over x, 2 plus 1, 3. Now, notice the way I differentiate this is a little bit different from what you normally do in school, in textbook. See, I like to use what we call the reciprocal form. It's a lot easier, a lot faster, because normally what we do is we will bring it up, differentiate, and then bring it back down. So in this method, it's faster. We put a negative in front. We copy a times n, copy x, you increase the power by 1. That's what I did here. I put a negative in front of b. I take b times 2 is 2b. I copy my x. Yet power is 2. You increase by 1. You get x cubed. And then we take this and compare with the gradient function that you are given. 2 plus 16 over x cubed. So you just compare. By comparison, you can find out what is your b. Negative 2b is now 16. Now we just compare the coefficient of 1 over x cubed. So b is negative 8. Right. Now, then we need to find the turning point, determine whether it's minimum or maximum. Okay, the turning point happens when dy dx is 0. Remember, it can be minimum, can be maximum at the turning point, or even inflection. Your gradient is always 0. So take 2 plus 16 over x cubed, let it be 0. Bring the 2 to the right, or you can multiply everything by x cubed as well. I just bring this up. Bring the x cubed up, bring the negative down. 16 divided negative 2 is negative 8, right? Cube root of negative 8, x is negative 2. And once you got the x value, you need to find your y value. Take this, put inside your equation of the curve. Now your x is minus 2, and you also know your b. Your b is negative 8. Divide by minus 2 squared. So this is minus 4. Minus 2 squared is 4. So minus 8 divided by 4, you get minus 2. Your y is negative 6. So your coordinate will be minus 2, minus 6. Now, next, you're supposed to do second order differentiation, or we call it second derivative, to determine whether it's minimum or maximum. Yeah, we basically take your dy dx over here. You can write this one, dy dx here. Differentiate one more time. When you differentiate 2, you get 0. When you differentiate 16 over x cubed, put a negative in front. 16 times 3, that is 48. Copy x, increase the power by 1, 3 plus 1, you get power 4. Now, let us substitute x with negative 2. Your d2y dx squared is therefore negative 48 over negative 2 power 4. So 48 divided by 16 is negative 3, right? Negative 2 power 4 is positive 16, yeah? This is less than 0. Remember, if it's more than 0 is minimum, if it's less than 0 is maximum. So therefore, this coordinate is a maximum point. Okay? Question number 10, this is from Form 5, Chapter 3, Integration. So diagram shows shaded region bounded by the curve y equals gx, the x-axis, and straight line x equals to 3. So given that area shaded region is 10, find the integration of x minus 2 x 2gx dx from 1 to 3. Now, based on our diagram, two things you need to know. Area under the graph represent the integration, right? So number 1, I know that this integration 1 to 3 gx dx is the area, right? But remember, when you integrate, and if the area is below the x-axis, the y value is negative. So therefore, the value or the result integration is also negative. So this is not just 10, this is negative 10. Yeah. integration 1 to 3 gx dx is negative 10. So we're going to use this result. Now, what we're finding is integration 1 to 3 x minus 2x 2 gx dx. So I'm going to break this up to integration 1 to 3 x dx minus 2, take out the 2, 1 to 3 gx dx. Okay, when you integrate x, you're going to increase the power by 1, 2, divide by 2, right? This is the general form. Limit is from 1 to 3. When you integrate 1 to 3 gx dx, this is already given, it's negative 10. So I'm going to substitute inside, negative 10. Now, let us substitute the upper limit, 3 square over 2, minus the lower limit, 1 square over 2. Negative times negative is positive 20. So here we have 9 minus 1, which is 8. 8 divided by 2, which is 4, right? 4 plus 20, answer is 24. You can use a calculator, right? Okay, next, you're given that the integration of gx minus 2 equals to derivative, g prime x equals to 2x minus 8. Find gx. So that means you're given basically the d by dx, the gradient function. You're finding your y. Gx is your y, yeah? Your y equals gx. So we can find your y or equation of the curve by integrating your gradient function. Integrate 2x minus 8. So this is x squared minus 8x plus c. So to find the value of c, we're going to sub in a coordinate, right? Sub in a coordinate. Any point, the coordinate I'm going to use is 1, 0. Sub in 1, 0. Okay. You can even use other point, but here's the problem. If some of you want to use 3, the problem is, do you know what's your y value? I don't know. But I know this. I know it lies on the x-axis, so your y value is 0, right? So sub y with 0, x with 1. Okay. So what's your c here? This is negative 7. Bring over c is just 7. So the equation of the curve y is x squared minus 8x plus 7. Okay. Oh, if you want, you can rewrite this as gx because they say gx in terms of x. So maybe I should rewrite because your y is gx. Yeah, your y is this. Therefore, gx is x squared minus 8x plus 7. Okay, so let's move on to question 11. This is from Form 5, Chapter 4, Permutation and Combination. So here diagram shows 6 workstations labeled P, Q, R, S, T, and U in a company. So 6 employees named Alif, Balkis, Christine, Daniel, Emir, and Faiz need to be placed in a workstation to work on various company projects. So each workstation can accommodate only 1 worker. So calculate the number of ways to accommodate all the company's employee if there's no condition imposed. So when there's no condition, right, you can put them anywhere, right? But it is in a what we call a circle, right? So A, you don't put the circle. A, there is no difference between putting P, Q, R, let me put next to it, S, T, U, like this, versus I put like this. It's the same because you also have 6 options for the first one, 5, 4, 3, 2, 1, right? So the number of ways the same as 6 factorial. You can use your calculator. 6 factorial is 720. Okay. Now, the second one, we're putting them in a circular workstation. So if you put them in a circular workstation, understand one thing, when you put them in the circle, right, the position of what we're interested in is who is seated next to who, left and right? So when you put them in the row, yes, 6 factorial, no problem. But when you join them together like this, right? Okay, this is just for the explanation that you don't have to do all this. So let's say, for example, I put 6 of them like this. And let's say I begin with P. I'm going to put P, yeah? So it's P, Q, R, S, T, U. So this is one arrangement. But let's say I start with U, followed by P, Q, R, S, T. So what will happen is U will sit here, P will sit here, Q will sit here, R will sit here, S will sit here, T will sit here. Now P will have the same person, the same U on the right, Q on the left, just like the first case. U on the right, Q on the left. So they are basically considered the same arrangement. So you don't want to double count them, right? So, and you notice that you can put P in 6 different positions. You can put P in the most on top, if you like, here, 3, 4, 5, 6. So to avoid double counting, or to count, like in this case, you're counting 6 times more, because you're going to rotate at 6 different positions. You're going to have the same person seated on the left and right. Yeah, just like this case, you notice. But if you arrange in the row, it's different. Huh? You arrange in the row, P is in the second position, right? This is P in the first position. But when you arrange the circle, P will have the same person seated left and right. So that's considered the same arrangement. So we always have to, either you take your 6 factorial divide by 6, or you take your 6, 6 factorial divide by 6 is 6 minus 1, or 5 factorial, right? Which gives us, calculator, 5 factorial is 120. Okay. Now, another way of thinking is this. Like, if you don't want to think about rotating like this, what you can do is that you can fix the position of the first person, right? You fix the first person, right? So let's say you put, who's the first person? Alif. You fix Alif. Okay, then you arrange the rest of them. Now, when you arrange the rest of them, you have 5, 4, 3, 2, 1, or we say 5 factorial ways of arranging them, which also gives us the same answer, 120. Okay. Okay, C is very interesting. If calculate number of ways to accommodate them, if Alif and Balkis cannot be accommodated in the workstation that shares an edge. Now, when you say shares an edge, means they cannot be next to each other like this. For example, P and Q next to each other, or P and S next to each other. They cannot be seated opposite this way or side by side. Yeah. So what is permissible? Yes, they can sit here and here, right? Or they can sit here and another position here, right? So this is a bit interesting because you need to break it up into 2 cases. Okay, so let me break up into the first case. We take the N workstation. Okay, let me draw a box to help you to understand. When you draw a box like this, you can put Alif here, right? Fixed position of Alif. Okay, so where can Balkis sit? Balkis cannot sit here. Cannot sit here. He has 3 other positions, right? You can put any other, there are actually 4 different ways that I can put Alif there, I can put Alif there, Balkis cannot sit here, 3 other position. Yeah, guys, you don't have to draw all these. So I can put Alif here, Balkis cannot sit here, 3 other possible position. I can put Alif here, Balkis cannot sit here, 3 other position. But one thing you got to think, there are 4 different positions to put Alif, to fix the position of Alif. Now, you cannot say, oh, I must times 2, because if Alif first, later, but now I fix Alif, then I fix Balkis. You can't do that. Why? So imagine if I put Alif here, then I put, let's say, Balkis here. Now I switch position. I put, let's say, I put Balkis, right? I can put Balkis here. I can put Balkis here, right? So let's say I put Balkis on this position. Then I put Alif. Then it becomes a overlap. Like I'm double counting them. Just like circular arrangement, because you're rotating A. It's like this is like a rotational symmetry, we call it. So A can be top right, top left, bottom right, bottom left, right? So that is 4 different positions. Now, if I reverse the position, then B and A will have the same position once again. So we only times 4. Then we think about 3 different positions to put Balkis, right? And once you fix Balkis, you still got 2 more positions, sorry, 4 other positions for the rest of them. This is the case where we put Alif or Balkis in the N workstation so that they are not next to each other. Okay. Yeah, I hope you understand when I say 4 of the rest, because once, for example, I put Aleph here, I put Balkis here, I still got 4 more people. So how many ways to arrange the rest? 4, 3, 2, 1, or 4 factorial, right? So calculation is 4 times 3 times 4 factorial. That gives us 288. Okay, let's consider the second case. Now, the first case I consider n-seed, because the n-seed you have more possibility to put the rest, right? Now, let's talk about the middle workstation, the middle seat, if you like. Okay, so when you talk about middle seat, right? Let me put Aleph here. Where can I put Balkis, or where can I not put Balkis? I cannot put Balkis here, cannot put him here, cannot put him here. So there are 2 possibilities I can put Balkis, the 2n, right? Now, likewise, I can also put Aleph down here. Okay, where can I not put Balkis? I can't put Balkis here, here, and here. Again, I can put on the other 2, top left and top right. So there are only 2 positions to fix Aleph, which is 2. How about Balkis? Also 2. How about the rest? 4 factorial. So just change this on your calculator. 2 times 2 times 4 factorial, you get 96. Okay, that's not done yet. What is your total? Take 288 plus 96. Okay, you will get 384. Yeah, 384. Okay, this is Form 5, Chapter 5, Probability Distribution, question number 12. So the first part is a binomial distribution. It is given that this is a graph of a binomial distribution where your n is 4 and probability of success is p. So you're supposed to express p in terms of m, okay? Now, one thing, if you look at this, right, you are given the probability for some of them, but you're not given probability of x equals 0 and x equals to 4. Your probability of x equals to 4 is now m. So if you want to find small p in terms of m, you got to use this. Yeah, if you use this x equals 0, then you will find in terms of k, right? I want in terms of m. So remember the formula. Let me write here. Px equals to x is ncx, p power x, q power n minus x, or you can use r. So your n is 4. C, your x is also 4. Your probability of success is p power 4. Q is probability of failure, is 4 minus 4. The result is m. Now 4C4 is actually 1. And this is q power 0. Q power 0 is also 1. Yeah, maybe I write one more step for you. So your p power 4 is m. P is m power 1 over 4. Yeah, there you go. You got your p in terms of m. Okay, second one you want to find in terms of k. The probability of x greater equals 1. We call this at least once, right? So 1, at least 1 is 1, 2, 3, 4. So rather than adding 1 by 1, right, it's easier to use total minus none, because the total probability is always 1, right? And the probability of none of x equals 0 is now k. So it's very simple. If you want to find x greater equals to 1, we use 1 minus x equals 0. The probability of x equals 0 is k. There you go. That's the answer. Yeah, 1 minus k. All right, moving on to part B. So there is a mistake in part B here, because they give us that x is a continuous random variable, right? And x follow a normal distribution. It's not binomial anymore, because this and this are the same. You notice that they make a mistake. They wrote this wrongly. So it's supposed to be x follow normal distribution. Mean is 48. Variance is 36. Remember, for normal distribution, they write like this. This is your mu, this is your variance, right? So here, we're supposed to draw the graph. Okay, so we sketch a graph, right? Just draw a smooth curve up and down like this. Okay, we know our mean is 48. Just write like that. Okay, this is your x value. You can add in your vertical axis. This is your fx. That's all. Okay, that's my graph. This side here a bit ugly. Let me just fix it. Okay. Okay, still a bit ugly. All right. Now, next, we're supposed to state the standard deviation. Okay, standard deviation is the square root of your variance. Your variance 36, right? If your variance 36, you take the square root of 36, your standard deviation is just 6. Yeah, very simple. All right. Okay. Question number 13. This is from Form 4, Chapter 4, Indices, Surds, and Logarithm. The first part is involving surd. So a research is carried out to find out insect attack on two field. Field A has breadth of 2 plus surd 3 acres. Actually shouldn't be, the breadth should be in meter, area should be acre. But anyway, whereas field B has breadth of 3 plus surd 3. So both field have the same length. So what's the ratio of field A to field B? So remember, length times breadth, they have the same length. But field A has width of 2 plus 3. Field B is actually wider. So I draw like this. Okay, sorry, my length not long enough. Maybe I draw further, like this is L as well, but this is 3 plus 3. So basically they share the same length, different breadth. So you're finding the ratio of the area, right? We just take the area, length times breadth, 2 plus 3, divide by length, 3 plus 3. We can cancel out the length. The length is not important. Yeah, we just have to simplify this ratio. So let us multiply top and bottom with 3 minus 3. 3 minus 3. Okay, so just rationalize the denominator. Basically, we multiply this inside 1 by 1. 1, 2, 3, 4. So 2 times 3 is going to give us 6. 2 times surd 3 is 2 surd 3. Surd 3 times 3 is 3 surd 3. Surd 3 times surd 3 is 3. And you divide it by 3 square is 9. Remember, this is a plus b, a minus b. When you square it, it's a square minus b square. So you get 9 minus 3. Now, we can simplify further. 6, you minus 3, you get 3. Minus 2 plus 3 is 1 surd 3. Then 9 minus 3 is 6. Can I simplify further? No, can't. And you can use your calculator. Let me show you here. When you take 2 plus surd 3, you divide by 3 plus 3, you should get this answer. Okay, so same answer. Okay, now when it comes to ratio, actually we can stop here because ratio we can write in as fraction actually, but the answer given, they write in this form, which is still fine. Yeah, you can write this form, you can write this form. Also okay, so that's a ratio. So I've got part A done. Second one, part B. Entomologists discovered that the insect attack on the plant area is given by the equation A equals to 1000 times 2 times 10 power 0.4 n, right? Where n is the number of weeks after the first inspection is done. So find the area after 5 weeks. So n is number of weeks. So we replace your n. This is B Roman 1. You replace your n with 5. So this is 1000 times 0.4 times 5 is 2 power 2, right? 0.4 times 5 is 2, 2 power 2 is 4. 4 times 1000, answer is 4000. Okay. Now, then next one. How long would it take for the attack to spread to area of 16,000? So let us replace your A with 16,000 and equate it with 1000 times 2 power 0.4 n. Very simple. This is a simple initial equation. Take 16,000 divided by 1000, you got 16 to power 0.4 n. Now, 16 itself is 2 power 4. When you compare them, you get 4, right? So n is 4 divide 0.4. When you divide with 0.4, is switch the decimal point. It's basically 40 divided by 4. N is 10. You can use a calculator, yeah? Okay. Okay, question number 14. This is from Form 4, Chapter 5, Progression. So diagram shows part several square drawn in a row. The length of side each square actually from a geometric progression. So the first square is okay, sorry. First time they say square, second part they say quadrilateral rectangle. Sorry, it's supposed to be square, it's supposed to be square or square. All right, is x, the ratio of the fourth to the first is 8 is to 27. So we're gonna let the first length is x, right? Your area, they say they're talking about length, they're not talking about area, right? You're supposed to find perimeter of the square in terms of x. Okay, the sixth one. Okay, so what is the perimeter of the first one? If maybe we find out what is the ratio of the fourth to the first one. Now, the first one is going to be x. The common ratio we don't know. D4 is basically AR. Let me just write this as 8 over 27 first. 8 over 27. D4 is A is x, right? Your R common ratio, I don't know. 4 minus 1. Your T1 is your x. 8 over 27. We can cross out the x. You're left with R power 3. If your R power 3 is 8 over 27, cube root of 8 over 27 is 2 over 3. Okay, first part. We got the common ratio, but we haven't finished yet. We are supposed to find the perimeter of the sixth square. It's not rectangle, it's a square. In terms of x. Okay, so what is a perimeter? Perimeter is basically you just have to times 4 because if this is x, this is x, this is x, this is x, right? So perimeter of, maybe you find the length of the sixth one first. The length of the sixth one is A, which is x. R is 2 over 3, power n minus 1. So that's power 5. So 2 power 5 is 32. 3 power 5 is 243. You can use your calculator. 243. Okay. Now, next, I need to find out what is the perimeter. You basically, there's an x here. X, basically, you just multiply by 4 because you need to find, let's say, for example, we know this is 32 over 2, 4, 3, x, very small. These all four sides are the same. So just multiply by 4. You should get 4 times 32 is 128 over 243x. Yeah, that's the answer. Okay, from the diagram, derive formula to find the sum of length of each side of the quadrilateral. Okay, now we're talking about length here. You take a sum of length. Now, we know for geometric progression, right? The sum of the first n term is given by A plus AR, next AR square, and so on. Yeah, you keep multiplying every term by R. So let's say the second last one will be AR n minus 1, sorry, n minus 2, the second last one. The last one will be AR n minus 1. Let's move this over a bit. So I'm going to call this equation number 1. So at the end of the day, we want to get rid of all the multiple terms in between. So what I want to get rid of this, right? All the in-between terms. So I would take equation 1, multiply by R. So you get R as n, A times R is AR times R is AR square times another R is AR cubed. This is AR n minus 2. You see, let me write here,
n minus 2, you multiply with r power 1, you get r power n minus 2 plus 1, which is r power n minus 1. So this one becomes n minus 1. And likewise, if you take r power n minus 1, you multiply by r, which is r power 1, you get r power n minus 1 plus 1, which is just ARN, equation number 2. My goal is to get rid of all the terms in between. Now, you notice when you take equation 1 minus equation 2, your Sn, you're going to minus your Rsn. But all this in between, you notice this one can cancel, this one can cancel, this one will cancel with the next one, this one will cancel with the one before, this will cancel with the second one before. You're left with the first and the last. That is, you're left with A minus ARN. Let us factorize the Sn. You're left with 1 minus R. Factorize the A. You're left with 1 minus R power n. And with that, we can divide everybody by 1 minus R. You will get this formula. Now, actually, there are two versions. The first version, you take equation 1 minus 2. This one is valid. Normally, we use this for R less than 1. The second version is Sn equals to A, 1, Rn minus 1, R minus 1. We use this in the event R is more than 1, but it doesn't matter. We can use it interchangeably, all right? Now, you don't have to show both. You show one will do. And since here you can see your rectangle or your square here is getting smaller and smaller, I will use the one with R is less than 1. Yeah, your R is getting smaller, right? Yeah, so there you go. We're done. This is how you derive the formula. Okay, let's move on to the last question. This is from, actually this is supposed to be function from 4 chapter 1, but it doesn't really look like a function question. All right, we have a price of an item, a Q of an item, and the quantity X sold follow the demand equation Q equals to 400 minus 1 over 4X, whereas cost D in RM to produce is given by this. You're assuming that D, you're finding D as a cost, is a function. D is a cost as a function of price Q. That means you're finding D in terms of Q. So if you want to find D in terms of Q, notice they share the same variable X, right? So I want to get rid of X. So we go back to Q equals to 400 minus 1 over 4X. Go back to this equation, make X a subject, right? Rearrange it, 1 over 4X equals to 400 minus Q. Multiply everybody by X. 400 times 4 is 1006 minus 4Q. Take this X value, sub inside your D. Your D is square root of X, which we can substitute inside. Minus 4Q, divide by 38 plus 900. Okay, 1600, you can take out 4, right? Take out 4, you're left with 400. Left with Q here, 4Q, you take out 4, left with Q, divide by 38 plus 900. So square root of 4 is 2. This is 400 minus Q, divide by 38 plus 900. 2 divided by 38 is 19, right? Then you plus with 900. Okay, it's not difficult, right? So you got your D in terms of Q. So this is part A. So part B, the cost of producing that item for 1 unit. Okay, if the item is sold at 39 ringgit, so that means your X, your Q, remember X is quantity, your X, your Q is the price, right? So you sub inside 36, 39 ringgit. Okay, very simple. It's sold at 39. Okay, so we substitute inside. D is square root 400 minus 39 divide 19 plus 900. Just use a calculator. Square root 400 minus 39 divide 19 plus 900. Okay, you should get 901. Okay, simple answer. D is your cost, 901. Okay, now see a bit like an overlap with B here. They say if one unit is sold at 76, previously sold at 39, now you sold at 76. They ask whether the cost will exceed 1000. Actually, we can tell from our diagram, from our equation. You see, if you increase the price, the cost actually will drop, right? I know it's very weird. Your price, because when you increase your Q, right, your D will be smaller, right? So, but in this case, since they give us the value already, you can just sub inside. Like you don't have to guess and or rationalize explain your answer, right? Unless they don't give us the price. If they say you sell the higher price, then what happened? Then you need to explain your answer. This one you don't need to. We can straight away substitute your Q with 76. It is going to be less than 900, right? Sorry, it's going to be less than 901. So it's not going to exceed 1000. So use a calculator. In fact, I can just use back this one, right? Just change it back to 76. You notice it's going to be less than 901, 900.95. Yeah, RM 900.95. So we say this is less than 1000. Answer is, oops. Answer is no. Would it exceed? Answer is no. Yeah, we already showed that it's less than that. Okay. All right, guys, this is the end of the discussion for paper 1 Pinang paper. Thank you for watching. See you in the next video.